I'm Anna Deming from Nanotech Web. It's in LA, in Cambridge, catching up on some of the emerging topics in large area electronics.
So my research interest is primarily focused on designing and synthesizing and eventually manufacturing reliably new functional materials and integrate them at large scale for functional applications. For example, in human-machine interface, human integrated technologies, wearable devices, and sensors. We work with one-dimensional nanowires of oxides, metals. We are also working with 2D materials. So recently we developed a method to mass produce two-dimensional materials at a very large scale through a solution method. So the human skin actually is a large organ. It contains many different types of sensors. And for tactile sensing or pressure sensing, we need the mechanical sensors embedded in your skin. Depending on the different areas of your skin, there are different numbers of sensors embedded. So fingertip is the most sensitive part of the human body. It contains around 200 such mechanical sensors per square meter for mechanical sensing. In our case, we are able to design and implement ultra high density, about 8,000 such sensor pixels within a square centimeter area. Of course, you can argue you don't need that high density, but because we want to demonstrate the capability, that is leveraged by our new device concept, which is a two-terminal device. So we remove the gate electrode. So for that special type of transistor, we call piezotronic transistor. It only has two terminals, and it can be directly controlled by mechanical signals. So mechanical signal like pressure, strain, functions essentially as the gate controlling signal to modulate the transport. So we think it's a simple but powerful design, especially for mechanical sensing and human-machine interfacing, compared to what we have from the silicon electronics. I think currently there have been numerous, huge amount of fantastic work exploring and understanding the fundamental science and the concepts in all the nanomaterials, including nanowires. But I think in order for the entire community to push it forward, to make something real, impactful to society, we must be able to come up with an economic approach or platforms to integrate those nanomaterials synergistically into a designed structure as per design. So for example, most of the research are still focusing on studying individual nanomaterials in the lab, which is very good. But you have to, just like the conference, many talks here provide, you need to integrate them at large scale, at a very low cost, so that you can truly make use of those new science and fantastic fundamental phenomena. So manufacturing I think is a next big question, and definitely we are working a lot, and I hope the entire community will devote more efforts towards that direction. In addition to understanding better the fundamental science, we need to develop manufacturable approaches to integrate, assemble, and fabricate the devices. First, the uniformity and reliability in producing those materials is a big challenge. So you can, for fundamental study, you can pick up one or two or a few working devices out of thousands of devices. But for any real products, you need to maintain at least a reasonable yield for production. And also, you need a uniformity, very good uniformity among all the material you produce within the batch. That's one big challenge. The second thing is, once you have this material, assuming they are uniform in property and structures, how can you assemble them in an ordered, aligned manner as per your design? That's another big challenge. So assembling after post-growth or synthesis assembly is a very big challenge as well. And last but not least, how can you synergistically integrate these functional new materials with existing electronic devices? Because you don't want to dump all the existing efforts away. You have to be synergistic and complement what we have right now. For example, silicon electronics. How can we integrate and holistically integrate new material into the silicon platform? That's another big challenge.